Hello, my name is Sir Isaac Newton. Linear kinetics is the study of the actions of forces, and to understand this we must first understand my laws of motion. These form part of the basic concepts and principles relating to linear kinetics. I defined 3 laws that relate to linear kinetics. These include the law of inertia, the law of acceleration, and the law of reaction. Now, my assistants are going to take you through a further explanation with an example of these concepts.
Newton's first law is the law of inertia. This is also known as the conservation of momentum. It states that a body will maintain a state of rest or constant velocity unless acted on by an external force that changes the state. The law of inertia can be seen in a motionless object such as a stationary ball. The ball will remain stationary until an external force acts on it, causing it to move, such as a person kicking it. Once the ball is moving, the ball will continue to travel at a constant speed and in a constant direction until an external force acts on it to stop it, such as another person stopping the ball with their foot or friction from the grass slowing it down.
Newton's second law is the law of acceleration. The acceleration of an object is dependent on 2 variables, the net force acting upon the object and the mass of that object. A force applied to a body causes acceleration of that body of a magnitude proportional to the force in the direction of the force and inversely proportional to the body's mass. When a football player throws a ball, the player is applying a force on the object. This causes the football to accelerate. We know that football accelerates because it starts from a resting point in the player's hand and then speeds up after the appropriate force is applied. The second law further tells us that the acceleration of the football also depends on its mass. If the player is throwing an extra heavy football, the acceleration of the ball would decrease compared to a lighter football that is thrown with the same amount of force.
Newton's third law is the law of reaction. The law states that for every action there is an equal and opposite reaction. When referring to forces, the law states that when one body exerts a force on a second, the second body exerts a reaction force that is equal in magnitude and opposite in direction on the first body. These forces are referred to as action and reaction forces. Forces always act in pairs and always act in opposite directions.
Newton's third law is evident when a swimmer uses their feet to push off the side of a pool. The swimmer exerts a force pushing against a pool wall and accelerates in the opposite direction of that push. The wall has exerted an equal and opposite force back on the swimmer. The feet exert a reaction force against the wall and the wall exerts an action force against the feet.
Thank you for listening to my assistants. Now let's summarise what we have learnt today. When a bowling ball hits a bowling pin, which exerts a larger force on the other? A, the bowling pin, B, the bowling ball, or C, the forces are equal? C is correct. The forces are equal in magnitude. Which has a greater acceleration, the bowling pin or the bowling ball? A, the bowling pin, B, the bowling ball, or C, acceleration is equal? A is correct. The bowling pin has a greater acceleration as it has less mass. You really know your stuff.